everybody. Hi, how are you doing? Today is December 1st, and I am not here today, but we are investigating sinusoidal functions. It's day 5, so I'm not here. The video is going to be posted right in the link right there. Our Unit 6 test is on Friday, December 9th. If you have any questions from yesterday's homework on angles and standard position, you can save them for tomorrow, or you can send me a message on Teams. All right, let's investigate sinusoidal functions. So sinusoidal functions are just periodic functions. They kind of look like this. Right? There's some like wave-looking function that forms symmetrical waves, where any portion of the wave can be translated into another portion of the wave. So we can this portion of the wave is also over here. A periodic function is a function in which the y values repeat at regular intervals. So we can see that their y values are all the same here, they're all the same down here, and so on. The x values will change. A period is the horizontal length of one cycle. So we're going to see like a cycle like this, right? And then it's kind of like where it repeats itself. So that this right here is what we call one period. So it's just this space right here. The axis is the halfway between the maximum and minimum. So we're going to look at the axis, which is this line right in the middle. It's halfway between the maximum and minimum values. And how we find this equation is we go the max plus the min divided by 2 gives us that line. And it should be a y equals line, right? Because it is a horizontal line. Our amplitude is the distance between the axis and how far up the maximum or how down the minimum is. Those spaces are always identical and they're called the amplitude. So it's the vertical distance between the function's axis and its maximum or minimum values, and the amplitude is found by taking your maximum, subtracting your minimum, and dividing by 2. A phase shift, which is very similar to moving the translation left or right, but this time we call it a phase shift, is how the graph is moving to the left or to the right. So, and anytime we're dealing with functions that are periodic, we call it a phase shift instead of a transformation. All right, so we're going to use our calculator and check out sine theta. And we're going to see what it looks like in terms of degrees. So from 0 to 360 degrees, we're going to go see where all these values are. So in your calculator, type in sine 0. Let me know what you get. Sine 0. Again, during these videos, you can press pause or you can rewind or fast forward at any point. All right, so sine at 0 is 0, right? Type in sine at 30. So sine at 30, again, make sure your calculator is in degrees and not in radians. And we're also writing to the nearest tenth here. All right, sine at 30, put in your calculator, what you get 0.5. All right, keep on going with all of these. I'm going to hit pause and I'm going to try them all out. All right, there, magic. Everything's all done. Okay, write them out and we're going to go graph. Once we graph these order pairs, so theta is going to be our x, sine theta is going to be our y, we're going to join them with a smooth curve. So at first, let's graph 0, 0, and then at 30, 0.5. So if that's 50, right? Then that means we're going up by 10. So 10, 20, 30. So at 30, we get 0.5. And then at 60, so that would be right here, 8, so not quite 9, just under. And then at 90, we get 1. All right, keep on going, and let's see that curve. All right, so it should look a little bit like this, and then we're going to make a nice curve, trying to hit all the points. And it shouldn't look like a V. There we are. And this is what we call y is equal to sine theta. Right. So use your graph to answer the following questions. What is the maximum value of sine? So the maximum value of sine is how tall is it? it's at 1. For what values of theta does the maximum value function occur? So we can see that the maximum value function for theta occurs at, this would be theta, this is not x, and this is our y. That theta is 90 degrees. What is the minimum value of y? We can see right here, it's at -1. And at which degree does this occur? It occurs at 270 degrees. And then using the formula stated above, what is the amplitude of the function? All right, the amplitude is equal to our maximum minus our minimum divided by 2. Our maximum is 1, our minimum is -1, and we're dividing by 2. So we get 2 divided by 2 is equal to 1, and it is. The span from here to here is equal to 1. We can see that right over here. Span from here to here, how tall this is also 1. So the amplitude is equal to 1. All right, let's go redraw sine theta below from -360 to 360. All right, so sine starts at 0. Let's call this 1 and this -1. At 90, I know it's 1, and we know we have other points in between, but these are like some of the main points. So at 0, 0, it goes to 1, then 180 goes back to 0, 270 is at -1, and 360 is at 0. So see, these are the main points. So no, it is not like this, okay? That's not like an N or some weird thing like that. It's got a smooth curve. In the opposite direction, it's got the reflection. All right, so here we have y is equal to sine theta. We're looking at backwards, but really it's the same function over and over. We can see that the distance here, which is the period, is 360. So we can see here that there's 1 sine and 2 kind of like pieces of sine happening. It's all sine theta, but there's 2 kind of graphed here between -360 and 360. All right, so use your graph to answer the questions below. We have, is it periodic? Yes, it's periodic. We can see that here. What is the period of the function? We just talked about that. It's 360. So it's 360 because you're even from this point to this point is 360. So it's always 360. Using your knowledge about functions, explain how you can verify that y theta is a function. How can you tell if something's a function? That's it. It's the VLT. It passes the VLT. And then state the domain and range. So our domain here, which we're looking at the graph going from this way. So for this one, it's only going between -360 but 360. But if sine were to continue on and on and on, it goes on forever. So theta is an element of the reals because theta is our x. You see that right here. Our range, just looking up and down, is only between -1 and 1. So y is an element of the reals such that -1 is between 1 and, so that's our domain in the range, between -1 and 1. There. Right. Next we're going to go check out cosine. So again, use your calculator set in, this time in radians, and we are going to go check out what cos is. So put your calculator in radians. If you don't know how to put your calculator in radians, you can Google it. And then go type in cos at 0. Cos at 0 is 1. Cos at, in bracket, pi over 6. Again, in radians, here we get 0.866. From radians here, we get 0.5, and keep on going. All right, so you put your calculator in radians, you typed in cos pi divided by 6 equals, again, it should be in radians, not degrees, and then you typed, and then you got 0.866, and then a whole bunch of other things, but we're just keeping these many decimal places. Nearest tenth. You can even do nearest tenth. Nearest tenth is 0.9. So let's even change that. That's the nearest tenth. I didn't change that on the other page. You can definitely do that. All right, so nearest tenth, that just means to 1 decimal place. Okay, let's go ahead and graph it. This is at 0 and 1. So 0, 1 is right here. And then we're at pi over 6. So this is like pi over 6. This would be pi over 3 and pi over 2. Pi over 6 is, so just a little bit down. And then pi over 3 is a half. And then 0. And then next we have 2 pi over 3 is at negative. And then a little bit that here. Well, hopefully, let's see. Here we go. What letter does this look like? If you said a U, yeah, it looks U-shaped. Definitely. It's still like similar to the sine function, right? It's actually very similar to sine function, but it's a kind of like a U-shaped I like to think of. And then what about like this one? This one kind of looks like a sideways, like almost like S-shaped. If you were to look at like from 0 and on, so that one looks U-shaped. Again, you can go change these to just to like 0.9 if you like. Okay, so what is the maximum value of cosine? Maximum cosine is 1. What is the maximum value of, where does this occur? At 0 and at 2 pi. What's the minimum? Minimum's -1. Where does this occur? Just at pi. Using the formula above, what's the amplitude? We can see it too. The amplitude is 1 subtract -1 over 2, or max minus our min divided by 2, which gives us, again, 1. We're going to graph it and state the domain between -2 pi to 2 pi. All right. Okay, so let's just label this as -1 and 1. So cos kind of looks like that U shape. Let's do this shape over here first at pi and at 2 pi. So at 0, it's at 1. At 2 pi, it's at 0. At pi, 3 pi over 2 is at 0, and 2 pi is at 1. There we go. We're going to go the opposite direction. So it looks like a sine function if you were to look at it right here, which it is. Cos and sine are very similar. They're just phase shifts of each other. So the domain here, oh, it's just saying that the domain is between -2 and pi and 2 pi. That's fine. All right, perfect. We don't have to state the domain. The graph is periodic. Oops. Running out of time. Yes, it's periodic. What is the period? It's 2 pi. So one period takes up this kind of one U shape. Then we have another U shape here. So one of them is 2 pi. User knowledge, is it a function? Yes. Passes a VLT. And then state the domain and range. Here we go. So this is for any cos. It doesn't have to be this one. So for any cosine, our domain is going to be theta is an element of the reals. It keeps on going on and on and on, while the range is only between -1 and 1. And that is saying y is less than or equal to 1 and y is greater than or equal to -1. All right, and please fill in a summary of what you see. Let's compare the differences and similarities. And so go back, graph it. We're just going to talk about the similarities and differences. So I want you to go back, graph the two functions again, fill in the period, fill in the minimum, maximum, amplitude, domain, and range for each of them. And let's go look at the similarities and differences. Right, so here's some of the similarities and differences. Give them a read and we'll talk about it more tomorrow. Have a good day. See you on Friday.